name is Todd Swank, and I'm the Vice President of Marketing at Nortech. And I'm here today with Dom Daninger, Vice President of Engineering for Nortech. And this is our second in a series of videos called What's New at Nortech. It's January 2012, and this month we're going to look in depth at one of a very large supercomputer that we're building for the University of Minnesota. Last month we looked at 5 different clusters we were building, and this month we thought it would be more interesting if we took a real in-depth look at one big cluster that we're building. And the one we've got selected today is a very impressive machine. It has 144 compute nodes along with the head node. It has 2312 CPU cores based on the AMD Opteron 6200 processor, formerly codenamed Interlagos. It has a whopping 4.624 terabytes of RAM, 73 terabytes of 73 terabytes of hard drive space, and utilizes QDR Infiniband. Dom, that's a pretty impressive machine. What do they need so much power for?
It is. It is. It is going to be used for computational fluid dynamics related to wind turbines and wind turbine farms, along with other computational fluid dynamics issues. This customer specializes in fluid dynamics and has done that for years and years, and that's becoming more and more a computational thing instead of actual physical models.
Okay. I'm a little confused. Computational fluid dynamics in a wind farm?
Yeah. What the idea is here is there is wind farms, as everybody knows, are becoming more popular, and because of their green aspects. And the thing that we're trying to do here in this program is improve the efficiency by anywhere from maybe 2% to 5%. When that doesn't sound like a lot, but if you look at the scales we're talking about here, it's huge. It's just one of these turbines supplies enough power for 600 homes.
Wow. So 2% is quite a bit of power still.
That's right. That's right.
So, and we're using the Opteron 6200s on this one?
Correct.
Well, that's
Correct.
A pretty new processor. Why did the customer go that route?
It's brand new. It boiled down to the best value for the dollar. The customer looked at everything that's available out there in the market and made the decision that this Interlagos 6200 Opteron gave him the best value for his dollar. And the thing he's looking at here is the most number of cores he can get for the dollar that are going to give him fast floating point performance. So that's what he needs for his job.
I also see that there's quite a few Mellanox QDR Infiniband switches in there.
Yes.
And that the benefit of that is?
It's what it is if we were to do the interconnect for the private MPI messages on the private network with Ethernet, gig Ethernet, we'd be looking at latencies of about 50 microseconds. When we instead do that with the quad data rate InfiniBand, we're looking at about 1.5 or maybe 1.2 microseconds.
Wow.
So huge gain in bandwidth and decrease in latency. And for applications like computational fluid dynamics, they're very chatty. So you have a lot of message traffic going not only between the head node and particular compute nodes, but internodal. You've got a lot of traffic because what you're doing is they basically build a mathematical grid, if you can imagine, around a turbine blade, let's say. And each one of those points represents velocities and vectors and pressures and different things like that. So anytime you change one of them, it influences everything around them. So you have to model that mathematically. And thus, that's why you have so much internodal communication, if you can kind of imagine this grid pattern there is represented by our compute nodes. So it's very complex, and bottom line is you get a tremendous performance gain by going with QDR Infiniband.
That's very impressive. And so using all these nodes and all this interconnection, I know we're using a different cluster management software than we've used recently.
Right.
Something called Warewulf?
Correct. It's out of Lawrence Berkeley National Labs. And the reason we went with that is to support the features that are incorporated in this Opteron 6200. We needed to have an extremely current kernel. So we had to be in a Red Hat 6.1 kernel or something, if it's a mainstream kernel, a 2.6.39 series or something like that, in order to incorporate support for some of the software features, some of the AVX and FMA4 features here that give a lot more processing capability to the instruction set. And interestingly enough, those features have to be supported in the kernel or it can't be incorporated. So we were, that's what motivated us to move to something that we could go in and put in the kernel we needed instead of a usual normal suite for cluster management where we're kind of locked into whatever kernel that's been built with. And so this Warewulf approach has got some real advantages. One of the other side advantages that we haven't taken advantage of, but some customers might elect to take advantage of it, is these nodes don't need hard drives. So that can be a big cost savings here today when hard drive prices are climbing.
Absolutely.
So.
And so is that kind of a unique feature of Warewulf, or is that?
It's not the only cluster management suite that'll support that, but it's one of them. And there is many out there that do require hard drives.
Okay.
And so it gives you the freedom to go either way. And in this case, we do have hard drives for scratch space, 73 terabytes. 73
terabytes. That actually leads a perfect lead into my next question. So you're doing something different with the hard drives than we've done a lot. I take it back, we've done it, but Lustre, storage management?
Well, what we're doing here is the 73 terabyte that we're referring to here is actually scratch space in the compute nodes. We've got storage outside of that that's attached to the Infiniband fabric here that's Lustre storage.
Okay.
And that's where the actual data will be stored and the user space and that kind of thing. The 73 terabytes is purely scratch space.
Okay.
And the advantage then of Lustre, which probably would be the next one, why use Lustre, it's very common in high performance computing and real high-end database applications. It's a parallel NFS or parallel network file system. And the neat thing about that, it's about one of the few solutions there where the more storage you have, the faster it gets. Okay. Because it becomes parallel, and you're always adding more storage in parallel to the existing storage.
Sure thing, sure. So that's a big theme in HPC as a whole, because I know we're going parallel across a lot of CPU cores and a lot of compute nodes, so it's the same basic concept, right? Where the more that you can write to at the same time, the quicker you're going to be. So, so you get the benefit on the storage side as well as on the processing side as well.
Exactly.
Well, very cool. This also uses a something called Torgue PBS Resource Manager. I'm not really familiar with what that is.
You got to imagine supercomputers like this may have tens or hundreds of users using them simultaneously, or you might even have a few users with a lot of different jobs that want to run. And what this does is allocates the schedule and the hardware resources amongst all those jobs, because a machine like this costs a lot of money, so you want to be able to utilize it, to its maximum capability. And this resource scheduler and resource managers, they help you do that.
Okay.
And what they'll do is as one job completes, that job may not have used the whole cluster. Oftentimes they'll not use the whole cluster. They'll use a portion of the cluster. And as soon as this resource manager and scheduler sees the availability of some resources out there, it'll stick another job in there that's been waiting in the queue. And so you can have queue priorities and all kinds of different things like that. And you can tie things to specific cores, and maybe you don't have maybe your nodes aren't all the same resources. Maybe some have more memory than others. Okay. So you may steer certain jobs towards those.
So you can dynamically allocate, I want these nodes to go towards this job and these nodes to go towards this job. Right. Now while Warewulf is doing kind of in the background where it's telling, I guess I'm still a little confused between the difference.
Warewulf is more of the cluster management, distributes the image and kind of sets up your parallel environment. Then the resource manager and the schedulers help you use that parallel environment efficiently.
Okay, well, very interesting. So.
Yeah.
Neat stuff. Is there other people besides Torque PBS? Is there other schedulers out there?
There certainly is. Moab is a commercial
sure.
one. Torque PBS is attractive in this case because it's open source.
Okay.
And it's using Maui also. So there's another open source. So, but there's a lot of different open source and there's a lot of different commercial.
That's right. We talked about Maui. Is that the reason that because it's named after the city in Hawaii, right?
That's right. Well, the Hawaiian Supercomputing Institute in Maui wrote it and developed it and is the maintainer of it.
Okay.
So, you gotta visit them.
Yeah, exactly. We're gonna set a trip to go out there very soon. So I guess one of the final things I want to talk about is, it seems like a minor detail, but one of the things I always hear about from customers with our clusters is just the level of detail that we pay to our cabling of the clusters.
Right.
And you think about that's such an afterthought for probably a lot of manufacturers, but at Nortech, I know our guys take a lot of steps there. Do you want to touch on that at all? And
I would agree that it does appear to be an afterthought, and if I go out in the field there and look at some of the existing installations done by either homebrew setups or the customers themselves or maybe some other vendors, it certainly doesn't look as clean as ours. We pay a lot of attention to detailing the cables. The cables are labeled at both ends. The ports that they attach to have matching labels. The cables are laid out so that they do not obstruct airflow, because we've got machines like this can generate a lot of heat. It's very important to get that heat away from the machine, so you want to have good clean airflow. Also, we lay the cables out so that these nodes, they can be removed and actually hot swapped right out of the, in each chassis, each one of these chassis is 2U, and then it has 4 nodes in each chassis, but one of those, if it needs maintenance, you can hot swap it out, but you can actually pull that out of there, and there's a very clear path for that. So it's that kind of thing that can really make a difference. And you've got thousands of cables back there, because there's actually 3 different networks back there. You have the MPI network, you've got the IPMI network for hardware management, and then you have the Infiniband network.
wow.
So, and a management network in some cases. So, it's an awful lot of cable.
Yeah, awful lot of cable. So it's nice to have those well organized. Well, thanks, Dom.
Sure.
And
You're
once
welcome.
again, this is Dom Daninger, Vice President of Engineering for Nortech, and I'm Todd Swank, Vice President of Marketing for Nortech. And if you'd like to learn more about Nortech's clusters or anything about us, please give me a call. My number is 877-808-7438, or feel free to visit our website at www.nortech.com. That's NOR-TECH.com. Thanks so much, and have a great day.